How do you turn JWTs into users in Spring Boot? Well, I've created countless Spring Boot apps, and in this video, I'll show you the approach that I use. This is part 5 of the event ticket platform build. If you haven't seen parts 1 through 4 yet, I'll link to those below. However, if you're just here to learn how to turn JWTs into users in Spring Boot, then stick around, because that's exactly what you'll learn. If you're here for the build, then this is the first one that introduces the front end, so you'll want to stick around for that. So all of the resources, including the Spring Boot backend source code and the React front-end source code, can be downloaded for free from the Devtiro Discord server. I'll put a link in the description below so you too can join the community. Okay, with that covered, let's get started. In this module, we'll implement the automatic creation of a user the first time that they interact with the REST API. As we need a user in order to create an event, this is a prerequisite to our create event functionality. The module is structured like this. We'll start by creating a custom filter for user provisioning. We'll then configure Spring to use the filter. We'll then enable the JPA audit field annotations. That's the created at and updated at annotations that we've added to our entities. And we need to enable these because we're using these on our user and they're a prerequisite to save the user. So now for the learning objectives. So by the end of this module, you'll be able to implement a filter to create new users in the database, configure Spring to use the user provisioning filter, and enable the created and last updated annotations used in entity classes. So with that covered, let's get started. Before we can create an event, we need an organizer user in the database. In this lesson, we'll implement the use of a provisioning filter, which will check the JWT in the authentication header and create a user in the database if needed. So here we are back in our IDE. So let's start in our repository layer, so in our persistence layer. So let's create a new package here, and I'm going to call this one repositories. And within repositories, I'm going to create a new Java class, and I'm going to call this one user repository. There we go, user repository, and it's going to be an interface rather than a class. There we go. So let's maximize this. We need our user repository to be able to save users in the database. And that's a basic create operation. So luckily, we don't have to implement anything custom for this. So if we put the @repository annotation on the top of this class to begin with, so we don't forget, marking this as a repository, and it will allow us to inject it throughout our application, we're going to extend JPA repository, passing in our user as the entity and UUID as their ID type. Let's just import UUID. Okay, so as a reminder, we already have our user entity. Looks a bit like this. The ID is a UUID type, and this has all the relationships and everything we need already set up. By extending JPA repository, if we were to control click through here, JPA repository itself extends the list CRUD repository, which extends the CRUD repository, which has a save operation already. So the user repository should give us everything that we need in order to create a user, save a user in the database. So next, let's create the provisioning filter. So we'll open up our project here, and I'm going to create a new package inside of Devtiro tickets, and I'm going to call this one filters. And within filters, I'm going to create a new Java class, calling this one user provisioning filter. Let's expand this. Okay, so I'm going to put the @component annotation on the top of this class to begin with. I'm not going to use @service because it's strictly not a service. We're going to use the more generic @component. That will allow us to inject things into this class and for the class to be injected where needed. Now, the important part, we're going to extend once per request filter. And you will notice that this comes to us from org Spring Framework web. So filters aren't a Spring concept. They're a servlet concept. But by using this, we can then inject things via Spring. By using the once per request filter, we can also make use of Spring Framework. Now we have a red squiggle. Let's hover over this, and it will tell us we need to implement some methods. So we'll need to implement do filter internal. Great. Okay, so let's put this on some new lines so we can read everything. Okay, and this is our to do. This is what we need to implement. So we know for a fact we're going to have our user repository in here, because that's the whole purpose of this filter. So I'm going to put the required Rs constructor on the top of this class, which will allow me, if I declare a private final user repository, we'll call that one user repository, This Lombok annotation will create a constructor for me, which will essentially inject user repository via Spring Framework. So we now have this user repository available to use in our implementation. So how are we going to implement this? So we're going to insert this filter after the Spring Security authentication has taken place, which means we should have access to that authentication object. So we're going to say security context holder dot get context dot get authentication. And we'll assign that to a variable called authentication. Now let's do some validation on this authentication object. Let's just scroll down a bit. So we're going to say if authentication is not null and authentication is authenticated and authentication dot get principal, and we'll use instance of in this case. I try to avoid it where I can, but I think it's necessary here, is instance of JWT, which comes to us from OAuth 2 JWT, and it's the type of the principal that we're expecting, at least when using the OAuth 2 resource server. Then what do we do? Well, let's put this on some new lines to begin with so you can read things. Let's just reformat this. Okay, so if the authentication object is not null, and if we're authenticated and the principal is a JWT, well, first of all, let's extract the KeyCloak ID, so the ID that KeyCloak has assigned to this user. So in order to do that, let's put the word JWT here. So we have reference to our JWT, and then we can say JWT dot, and let's say get subject, because the subject is going to be the user's ID, and it's going to be a UUID. Now I'm going to say UUID from string, which isn't completely safe. So if it did throw an exception for whatever reason, bubbling up to the top may not be the worst thing. So let's assign this to a variable, and I'm going to call this one KeyCloak ID. Now let's check whether or not our user exists. And for that, we're going to use the user repository. So we'll say if the user repository exists by ID, passing in the KeyCloak ID. So if the user, exclamation mark at the front there. So if the user does not exist in the database, then we'll go about creating a user. So we're going to say user equals new user. There we go. Now, although we did annotate our user objects or user entities, or in fact, all of our entities with the app builder annotation, having thought about it, I'm deciding against using builder. And I've come to that conclusion for a couple of reasons. Builder is great. However, it does require us to put additional annotations on instance variables where we have initialized collections. At the moment, the builder would completely ignore this new array list and would assign null to staffing events. In addition to that, we've also made use of the JPA order annotations like created date and last modified date. So I'd rather not cause any issues for that. I'd rather that work as expected. So with that in mind, then the value of using builder is sort of outweighed by the risks of using builder. So I am going to remove it from the user class while we're here, and we'll continue our implementation of the user provisioning filter now. So let's just remind ourselves what a user has. So if we split the screen for a moment and then have our user provisioning filter here. So on the user, we're going to set the ID first of all. So user.setID is going to be the ID from KeyCloak. We want to make sure that they match. The name, well, let's say user.setName, and we can extract the name claim. Its preferred username is the one that KeyCloak uses. So we can say jwt.getClaims.get, and we'll say preferred underscore username, and we'll call toString on that. In fact, let's put this on some new lines so we can read everything. That looks a bit odd. Let's see if we can reformat that. Okay, let's just scroll down here. We'll just leave that on one line. That format's a bit strange. That will do. So we're setting the name on the user. We want to set the email as well. Then we have organized events, attending events, staffing events, created at and updated at, which will be populated for us, equals and hash code. So we only really need to worry about setting the email other than what we've already done. So let's close that so we can see everything. And let's say user.setEmail, and we'll say jwt.getClaims. Although strictly speaking, we could do getClaim as string and do it that way, email. In fact, let's do that up here, and then we can have a bit cleaner code. That's much better. There we go. So if the user does not exist, the user identified by this KeyCloak ID, then we're going to create a new user entity We're going to set the ID, the Keycloak ID, on the user. We'll then set the name from the preferred username claim that Keycloak uses as a part of OpenID Connect. We'll also set the email from the email claim. And then all that's left for us to do now is say user repository.save, and we'll save the user in the database. And then right at the end, so outside of all of the ifs, let's just minimize this so it's obvious. We'll want to call filter chain dot do filter request and then response. And that will continue the filter chain. So as a high level summary of this component, we are extracting the authentication object. We're checking it's not null. We're checking that the user is authenticated. We're then extracting the principal, which is going to be of type JWT. If it is, then we're going to extract the subject, which is the UUID, into this variable Keycloak ID, which should identify the user in our database also. So we'll check whether or not the user exists by ID in the database. And if they do not, then we need to create them. So go about creating them by creating a new user entity, setting the ID, the username from the preferred username claim, and then the email from the email claim, and then saving that user in the database. And then we continue with the filter chain. So in summary, we created the user repository interface and implemented the user provisioning filter. Creating a filter isn't enough. We also need to configure Spring Security in order to use it. In this lesson, we'll create a Spring Security configuration file. So back in our IDE, let's create a new package in Devtiro tickets, and we'll call this one config. And within config, we'll create a new Java class, and we'll call this one security config. Let's expand this. So security config is going to be a configuration class. So let's add the configuration annotation to the top here. Now we're going to use this to configure Spring Security. We're going to insert the filter that we've just created into the filter chain. So for that, we'll need to declare the appropriate bean. So we'll say bean, public, and it's the security filter chain. We'll call this one filter chain, and it takes a HTTP security. We'll call that one HTTP. And then we'll also inject the user provisioning filter, which we'll call user provisioning filter. And that's the filter that we've just created. Let's put this on some new lines. Great. Now this will throw an exception. Now we can get to implementing this. So we're going to call HTTP dot authorize HTTP requests. Whenever we configure the Spring Security filter chain, we definitely want to make sure that all requests are authenticated. So within here, it's a Lambda. We're going to specify authorize as the parameter name. And then we'll say authorize dot any request dot authenticated. So this is like a catch-all rule, basically saying every single request will be authenticated by default. So next, we're going to call .csrf. Now, although it's completely possible to use CSRF with a REST API, we're not going to in this particular implementation. And you'll find that's not particularly uncommon out in the wild. However, of course, if you do use a CSRF token mechanism, you will benefit from that additional security. CSRF, and we'll say CSRF dot disable. Next, let's deal with session management. As we have a REST API, or as we're building a REST API, it can be completely stateless. So let's specify that so we don't have any overhead from managing sessions. So this is also a Lambda, session management. On session, we're going to call session creation policy, and we're going to set that to session creation policy stateless. Okay, so as we're replacing the security filter chain bean, we should also specify the OAuth 2 resource server configuration. We'll call this one OAuth 2, and we'll say OAuth 2 dot JWT. And you'll notice actually, if we do this, we have a deprecated JWT call here. So the way of calling this has changed recently, or fairly recently. So we'll say JWT, and then we'll say customizer with defaults. We're just going to use the default configuration, and then we're going to add our filter. So add filter after, and we're going to add the user provisioning filter, which we've injected up here. And we're going to add it after the bearer token authentication filter. like so. And that should make sure that the authentication object is present and the user is authenticated. And with that done, all that we have left to do here is return http.build. There we go. So we now have configured our security filter chain. But there is some additional configuration required before we can test this out. And that has to do with the JPA audit fields that we're using on our entities. So in summary, we created a basic Spring Security configuration file. We disabled the CSRF mechanism on our REST API, and we configured Spring Security to be stateless, and we configured Spring Security to use the user provisioning filter. So simply adding the created at and updated at annotations to entities isn't enough to populate these variables with data. We also need to enable Spring's JPA audit functionality. In this lesson, we'll do just that. So when creating our entities, here we have our user, we added these audit fields. We added the created at and updated at audit fields. And we did this as a best practice because we want to know when these entities are created and updated. And to make things easy, we've used this at created date and at last modified date annotations. There are various different ways to enable these annotations. They're not enabled out of the box. The way that we're going to do today is the way of enabling them globally for our application rather than adding annotations to each entity individually. So to get started, we're going to go to our project, go to our config directory, create a new Java class, and we're going to call this one JPA configuration. And we're going to add the at configuration annotation to the top of this. And we're going to add at enable JPA auditing. And the class, other than this, is going to be completely empty. At enable JPA auditing is the key annotation that we want here. So the next step is to update a configuration file. So to do that, we're going to go to the resources directory. So source main resources. And within here, we're going to create a new directory. And the name of this directory is very specific. Capitals, meta-inf. And within this new directory, we're going to create a new file called orm.xml. So before we go any further, because I appreciate this is quite an odd approach, I just want to draw your attention to the documentation here. So JPA auditing documentation, we can see here created by, created date. So we can actually store the principal using these annotations also. But if we scroll down here, here we go. So the configuration. So we need to register a auditing entity listener. And to do so, we're going to configure our orm.xml. And here we can see an example right here. The alternative that I mentioned earlier is we can put the at entity listeners annotation on each of our entities. However, if we can update it globally, like we're going to, that's my preferred solution. So orm.xml. Now, unfortunately, the XML example there wasn't complete. So this is what I've come to make things work. Let's just expand this. So you can see here, we have the auditing entity listener, fully qualified in entity listeners inside of our orm.xml. And I'll put this in the lesson notes so you can paste this in as well. Now you might be wondering about this meta-inf directory, but basically when the application is built, anything in this directory will be bundled in, and therefore the configuration file will be made available to Hibernate when it's running. So with that, we have now enabled our JPA audit annotations. So in summary, we've created the JPA configuration class with the at enable JPA auditing annotation. And we've added the orm.xml configuration file enabling the audit fields. So let's recall what we've achieved in the user provisioning module. In user provisioning filter, we created the user repository interface. We implemented the user provisioning filter. In Spring Security configuration, we created a basic Spring Security configuration file. We disabled the CSRF mechanism on our REST API, and we configured Spring Security to be stateless. And we configured Spring Security to use the user provisioning filter. In Enable Spring JPA Audit, we created the JPA configuration class with the at enable JPA auditing annotation. And we added the orm.xml configuration file enabling the JPA audit fields. In this module, we'll implement the create event endpoint, allowing a user to create an event in our system. The module is structured like this. We'll start by designing the implementation. We'll then add any custom exceptions that we're going to need. We'll then implement the service layer. We'll then implement DTOs and mappers, and that will allow us to implement the REST API endpoint. We'll then add error handling. returning any errors in the correct format and with the correct status codes. We'll then test our brand new Create Event feature. So now for the learning objectives. So by the end of this module, you'll be able to summarize the user interface and any additional requirements it introduces to the backend implementation. Design the Create Event service layer implementation. Implement an exception thrown when expected users do not exist. Implement the Create Event business logic in the backend. Implement the DTOs and mappers required to create an event in the backend. Implement the Create Event REST API endpoint, and appropriately return errors to the callers of the REST API. And finally, test if the Create Event functionality is working by using the user interface. So with that covered, let's get started. In this lesson, we'll review the user interface and consider anything that we need to bear in mind when we implement the Create Events endpoint. So here I have the front-end code, and you can download this from the Devtiro Discord server. Now what makes this build different from others is that this isn't the completed front-end. This is just the first iteration. So you'll see this evolve over time as the backend evolves as well. And that should hopefully represent the real way that these things are developed. So now that we have the code locally, how do we run it? Well, first things first, we need to run npm install. This will install the dependencies. Now here's the thing, we have a bunch of errors here, but that's sort of expected. So because of the dependencies that we're using, shadcn specifically, we do have some conflicts. However, this is all documented on their website and should hopefully go away soon. So for the time being, rather than npm install, you may need to use --force. So with that done, what we can do is go npm run and dev, and that will run the dev server, making our application available on localhost port 5173. So if we copy this and then go to this address in our browser, here we are, a pretty anticlimactic white page with a login button. However, this isn't what we're going to be using. This is just the default landing page, which will eventually be where people will go in order to search for tickets for events. We're currently implementing the organizers flow. So if we were to go to /organizers, so here we have something that's slightly more refined. So this is the implementation of the designs. As a reminder, the designs for the organizers landing page looked a bit like this. Let's just zoom out a little bit. So we were to have some login buttons in the top right here. We'd have some text here, an image on the right, create event, and then browse events. At the moment, we're implementing the create event flow. So it's only the create event that's been implemented. Now something else that's different for this particular build is I've recorded the entire front end build as well, and that's available over on devtiro.com. So this is a design, and this is our page. So let's go to create an event. So we've been redirected to the login page. So this is Keycloak. The username that we're using was organizer and the password was password. We've been warned to change our password naturally as it's not very secure at all, but this is my local dev environment. And here we are on the create event page. Now this is the first iteration and this will be refined over time as well. However, we have our navbar at the top here. We have our OR for organizer user, the email address of the organizer user here, the ability to log out. And then we have the form for creating a new event. So again, as a reminder, let's look at the design for this. So that's our landing page. So the design for this one, we didn't really have a lot to go on. We knew that we wanted a navbar of some kind, we wanted a title, a subtitle, and then the various input fields in order to create an event. We hadn't really nailed down what the structure would look like at that time. This is what we have at the moment. So we're able to specify the event's name, and then optionally, because when we were doing our domain modeling, we decided that start and end, in fact, event start and end, event sale start and end, they would all be optional. So if we did want to provide those, we could go ahead and provide a date and a time. That would then be sent to the REST API. We have our venue details. So we learned from the user personas that some users want a lot of details about the venue, so we've made this a text area. At the moment, venue details is only a string, but we could build that out to be a more elaborate object in future if we choose to. So event start, event end, venue details, event sales start and event sales end, so when tickets go on sale and when tickets stop being on sale. Again, optional. And then we have the ability to add ticket types. So when we were modeling our domain, we decided that An event can have multiple ticket types, so we use this in order to add those ticket types. We may want to define a VIP ticket. It may want to be, say, 99. Total available might be 100. And we can also add a description in there for that particular ticket type as well. We can also go ahead and edit it, and we can also delete it as well. And then we're able to specify the status of our event. Is it draft? Is it published? And within the front end, this builds up a JSON object. And when we click on submit, that will then be posted to the Spring Boot backend that we're building to the endpoint that we're going to implement in this module. Now, something I should point out because it's rather important. If we go into the ticket type here, we have name, we have price, we have total available. And we sort of glanced over the fact that there's this description. Description is a new field that the front-end developer, myself, introduced as a part of the front-end development process. Again, this happens a lot in real life. So we're going to incorporate this new field into our ticket type object on the back end when we implement our endpoint. But as it stands, this is an overview of the first iteration of the create event page. So in summary, the user interface can be used to create an event, and a field name description has been added to the ticket type object. In this lesson, we're going to design our create event endpoint. That's going to include creating interfaces this endpoint might need. So we're back in our IDE. So before we go any further, we've recently learned about a new field that's going to be on one of our objects. It's going to be on the ticket type object here. And let's expand this. And we scroll up here. It's going to be somewhere here. So let's add a private string description to our ticket type. And we'll add this as well. So we'll say that the name is going to be description. It's now the decision to make it nullable or not. I think we should make it nullable. There we go. So we now have this new description field. So with that done then, let's design the object that we're going to use to create an event. So let's open up our project. And within domain, I'm going to create a new sub package, and I'm going to call this one entities. And everything that's there at the moment, I'm going to drag into entities. We'll click on refactor, and we'll do this in order to keep things organized. So the object that we are to create is going to model the create event request. So we're going to right click, go new Java class, create event request. And let's add that. But I don't want that to be in domain entities. I'm going to refactor and move this class to be in domain, because strictly speaking, this isn't going to be an entity. Let's open up domain. There's our create event request. Now, perhaps the easiest way to model this is to get our event entity on the right-hand side, and then we can have our create event request on the left. Okay, so let's add the data annotation to create event request. It's safe in this particular case because there isn't going to be any bidirectional relationships. And let's say all R's constructor, no R's constructor, and that should do for the moment. So what information are we going to need in order to create an event? We're not going to need the ID because the server, our Spring Boot backend, is going to generate one. So we can omit that. We are going to need a name, so private string name. Start date, yes, we'll need one of those, although it is optional, but it can be made null, so that's fine. And we're also going to need an end date, which we have there. String venue, yes, we'll also have one of those. Sales start, absolutely, we're going to include that too. Sales end, and now status. So this is an interesting thing. So we're using the event status enum here, and that's completely reasonable to use in our persistence and service layers. Some may argue that you should have different enums for your presentation layer that then map to the enums used inside of your service and persistence layers. Others may argue that enumerations like this are part of the vocabulary of your domain and therefore should go cross-layer, as it were. We're going to do the latter. So we're going to take that status, event status enum, and place it into our create event request. Now we start getting into the objects that event relates to. So we have here the organizer of the event. I'm going to choose to include this in the create event request object. And the reason being is that we can get the user and pass that in to the service layer. So we'll include user. We'll not include attendees. We'll not include staff. And now for ticket types. So we do want to represent ticket types in our create event request. However, it doesn't feel right to use the ticket type object because the object that we're modeling on the left, the create event request, its only purpose is to provide the information to create an event. Whereas ticket type, this one referenced on the right here, is an entity. So here's what we're going to do. We'll open up project. Inside of domain, we'll create a new Java class and we'll call this one create ticket type request. And this will be a Java class. Let's close project on the left and let's move create ticket type to the left. Okay, we'll add data, all R's constructor and no R's constructor onto our class here. And I'm going to control click through into ticket type on the right, which is placed on the left. So let's drag that. Okay, that took a bit of effort, but we have the ticket type entity on the right and the create ticket type request on the left now. So what information do we need in order to create a ticket type? We can omit the ID because the server will generate one. We do need the name. So we'll place that into our create ticket type request. We do need a price. The description, our new field, we should include that. Total available, we should also include that. And then we have the relationship between ticket type and event. We won't include that. We won't include tickets because we're simply creating the ticket type here. We're not creating any tickets. And we're, of course, not going to include any audit fields. And then we have the equals and hash code, which will regenerate actually while we're here on ticket type because we've introduced a new field. Equals and hash code. Next. So we'll include ID, name, price, description, total available. We won't include event. We won't include tickets because we don't want to trigger any bi-directional relationships. Next. Create. Okay. So with that done then, I think the create ticket type request object that we have now contains all the information that we need to create a ticket type, which is fantastic because we can close this and close this. And then in our create event request, we can say private list of create ticket type request, and we'll call this one ticket types. And we'll initialize that to be a new array list. And we'll need to import list. There we go, had to import that one manually for some reason. So we're representing the organizer of the event. We're representing the ticket types. We're not going to include the created at or updated at. So I think that's it. So the goal for this object is to capture all the information that we need in order to create an event, because we're going to use this object in our interface that we're going to create in one moment. So you might be wondering, why have we included user in this, which is very much an entity, but we've created a brand new create ticket type request object to represent ticket types. The caller won't be providing the user object. We'll be loading that again from the service layer and then passing it through. However, the representation of the ticket type, and in fact the representation of the event itself, that will be passed in from the user, so the caller of the REST API. So although we could decouple this and use a different user representation, I feel that may have been a bit overkill at this particular time. So we have our create event request object. How do we use it? If we open up project here, and we're going to create a new package inside of Devtiro tickets, and we're going to call this one services. And within services, we're going to create a new Java class, and I'm going to call this one event service, but it's not going to be a class, it's going to be an interface. And I was just about to close projects on the left here, but I've noticed there's a typo in repositories, REST repositories. So let's refactor, rename that, and correct that typo while we're here. Refactor. There we go. The Boy Scout rule in action. So let's minimize that now. So this interface is to represent the event service, a service that's concerned with managing events, their entire life cycle. So we're going to declare a method on the event service, and I'm going to call this one create event. It's going to return an event, so the entity, the event that's been created. The method's called create event, and now we get to declare the arguments. So we're certainly going to need to pass in the create event request, and we'll call that one event. That's the representation of the event that we are to create. However, having just explained the representation of user inside of create event request, I'm starting to feel like there may be a better solution. So I'm going to remove organizer from create event request here. So this only contains the information that represents the event. What I'm going to do instead is over on event service, I'm going to say that the caller must specify the UUID, which will import the organizer ID, like so. So in order to create an event, the caller of this particular method must provide the organizer ID and the bare minimum information required to create an event as represented by the create event request. And that feels like a much cleaner implementation than including the organizer user in this particular class. So in summary, we implemented the create ticket type request class, and that represents the bare minimum information to create a ticket type. We implemented the create event request class, representing the bare minimum information to create an event. And we created the event service interface, which declares the create event method, a method which, once implemented, we'll use to create an event in the application. Having just designed the event service that we'll use to create an event, we know that we're going to be passed the organizer's ID and that we must link a user to an event. The thing is, the user identified by that ID may not exist. So in this lesson, we're going to create the exceptions that we'll use when the user cannot be found. So here we are back in our IDE. So let's create the exception that we'll use when a user cannot be found. So we'll create a new package inside of Devtiro tickets, and that's going to be called exceptions. And within exceptions, I'm going to create a new class, and I'm going to call this one event ticket exception, and it will be a class. Now you might be wondering why I've created such a generically named class. Well, the reason for this is I intend for this particular class to be the parent of all custom exceptions that we'll use in this particular application. And that has the benefit of keeping things organized. But it also allows us to, when we define a catch, we can specify this particular exception type and be confident that it will catch all of our custom exceptions. Let's just expand this. So which exception class are we going to extend? We're going to extend the runtime exception. And that means that we don't have to declare throws of the exception on any methods that throw this exception. The rationale for doing this is that by using a checked exception, so if we were to extend exception, Uncle Bob argues that this will break the open-close principle, and therefore he recommends that we use runtime exception. So this is in the clean code book. So we're going to use runtime exception for this. Now, with an exception, we'll need to declare which constructors that we want to use. So let's right-click, and we'll go Generate, Constructor, and we're going to select all of them. And click OK. It's generally good practice to include all of the constructors, like so. So we now have this generic base custom exception. We're going to create the exception now that represents the user not found. So over in exceptions, I'm going to create a new Java class, and I'm going to call this one user not found exception. And it's going to be a class. And we'll extend our event ticket exception. And then we'll right click in here and we'll go Generate, Constructor, Control A to select all, and then OK. There we go. We now have a custom exception that we can use to represent a user not found. So in summary, we created an event ticket exception, parent custom exception. And we created the user not found exception to represent the invalid state when a specified user does not exist. So we're creating users from JWTs, and we've started to implement our create event functionality. If you look up here, you should see the next video in the series. And if you don't see it, it means it's not out yet. So be sure to subscribe to be notified when it does come out. If you want even more Devtiro today, right now, then I'll put a link below for devtiro.com, where you'll find all of the content that you won't find here on YouTube. Or if you prefer, why not check this out?